Hello, it's Piers from Jersey Laser Scanning. I'd like to introduce or clarify the inspection functions available to surveyors of drones and ground-based LiDAR and things like that. Um, Jersey Laser Scanning is offering this inspection method, and I'd like to just quickly show you the various bits of software that one can use and how you can use it. We are obviously still continuing to do survey work, um, but here we are. Here we have an iconic um, area in Jersey, which we have created a Revit file for, and so it's all heavily detailed. Now, let's say, for example, that one wanted to compare this wonderful old structure over time, just to see how things were changing, if at all, or confirm that they are not changing. How will we go about that? Well, um, if we look at this file and we hide all of the model as well as these levels, we're left with a couple of point clouds. One is the point cloud, which you can see very clearly on the screen. It's the very large one, including the beach and so on, and that was collected by a drone. And we've also got um, the another point cloud, which is an area which the drone wasn't ideally suited for, which was the area underneath, or had an overhang. And so we did that with ground-based LiDAR. And we combined the two. And after combining the two, we had a consolidated geo-referenced and accurate point cloud um, from which we did the survey drawings. So let's say we wanted to compare this structure over time to see if any movement was taking place, and if so, what. Um, how would we do that? Well, we've got a drone point cloud, we've got a ground-based LiDAR point cloud, and I'm just referring to my notes. There are one, two, three programs which we can use, which will really bring out um, uh, if any changes have taken place over time by flying exactly the same mission which has been saved um, for the drone, or recording the same location with ground-based LiDAR. So first of all, let's look at Agisoft Cloud Viewer. Now, this can be sent um, via an email link. It's uploaded, it's photorealistic, and if I just click on the images here, you'll get to see that as in another video I've done on our YouTube channel, and if you look at Archie Rondell, or look up Archie Rondell, you'll see the different method used for getting inspection levels of detail. And that's what was used on this particular location. Again, relatively iconic in Jersey. Um, and so I'll just bring up the images again so you can see how close the drone was flying. And this is the original flight. We call it a standard flight overhead, and this was the resulting second flight. So what's this providing us? It's providing us um, an extremely high detailed. I keep using the expression photorealistic, but it is literally using the photographs and superimposing it on a triangulated mesh in this case. And one could just move around and almost carry out the inspection from here. But let's say that let's say that isn't good enough. And what you'd like to do is access the real photography that was taken, which is the way it has been done. But instead of lists and lists of hundreds of photographs, where you'd have to navigate through them until you got to the point that you wanted to look at, um, how would you do that? How would you combine it with this particular example? Well, you would go to the inspection function, and you would identify a location where you might be interested in. I'm literally picking a random point. So if you zoom in, more detail comes in. So let's say the center of this white object, if you click on it, and then you're in one is in inspection mode here, you left click on the photography, and you can see the green cross that I had on the other screen, the model, should we call it, um, is identified here, and you can see the real photography. And you can move through these until you find the direction or area of interest that one would like. What other capabilities has this Agisoft Cloud Viewer got? Well, if I come out of inspection function, let's look at the tower again, say in its entirety. Um, you can go to a compare function. So we go to compare here. Now I've only got one scan of this location, but on the left-hand side is blue, on the right-hand side is green, and on the left-hand side of the screen here, you'll see left-hand side is blue and right-hand side is green. Uh, one can put in an identical scan of the same object on a different date and zoom in to any areas of interest and compare the two against one another. Now, it doesn't work very well for this, and um, uh, we need a second scan to see how things have changed. But this is an ability to compare something visually over time, inspect the photography, as well as have a clear orientation um, capability. So you can go to areas that are of interest. But this is still a very large tower, and someone still has to go through this unless they're looking for something specific and they're looking for a specific area. Painstakingly go through, maybe inspect all the photographs in a location, or look at things. Let me just come out of this comparison mode. And I mean, it's pretty good. It's very good at it, I think. But let's say one wanted to have some visual aids to something that would draw one's attention to areas that might be of interest. You would probably do that through a program called Cloud Compare. Well, that's what we use anyway. So this is the original Revit file, and I've identified that I want to do either a close-up flight, should we say, of this sea wall, or I want to conduct an identical mission above and see what detail comes out and how things might have changed. But I want some sort of visual guidance on some areas that might be of interest. How would we do that? Well, we would use Cloud Compare. Now, this is an example, and I am pixelating out or redacting the relevant information. So although these are really good examples, as in nothing really moved, um, I would like to give it a bit more detail and context so you can apply that to whatever object that you would like to inspect or check on. So here we have a, a facade, and this is a decimated version. And for those that don't know what that means, it's essentially instead of getting the maximum resolution on this, which would look something like this, and there's a delay to it because it's very, very heavy on the computer, and one can't really rotate it. Um, I'm showing you a decimated version, so we get very quickly onto target, and then we can look at the more detailed version. So what are we looking at? We're looking at a strange multicolored object. What this is using ground-based LiDAR. It works in an identical way to the drone-based point clouds. This is a ground-based point cloud from a LiDAR scanner. Um, you scan a location before some work may be done, and you scan the location after some work has been done, and one can compare the two point clouds. And point cloud is essentially a cloud of point measurements, accurate point measurements. And this cloud is the cloud of the scan after the work that was done, but it's being compared to the scan before the work was done and colorized accordingly to distance between the two scans. I hope that made sense. Um, on the right hand side, you can see cloud to cloud absolute distances. So 0 will be blue, and anything moving further out into the green, yellow, or red regions could be either side of um, the latest scan that one did. So it could be into the wall or further out from the wall, but it would draw your attention to it. So then you could go and look at it and identify that. So in this case, I drew the scale to a maximum of 3 centimeters. Anything beyond that is black. Hence, you can see what's going on here in the lower part of the screen. And I've got the panoramic photography that was available at the time, and you'll see why these areas are black, because there has been a greater movement than 3 centimeters. Anything that is red, um, example in here, means that it is 3 centimeters approximately. When I say approximately, because I can't tell exactly what shade of red that is, according to the scale over here, but it's showing me that something is up to 3 centimeters different between the two scans, which were done over different periods of time. So we look at green bits down here. So I'm going to go with a lime green color. That's in the region of 1 to 1.5 centimeters different, um, and so on. And the blue is obviously minimal changes between the two. So why am I showing you this example, and how am I going to translate it into something that makes a bit more sense? Well, ultimately, there are areas in this which are red. So one wants to look at this more closely. And if I was doing an inspection, or Jersey Laser Scanning was doing an inspection, um, one would record the data on one date, record the data on another date, and put it into Agisoft Cloud Viewer, and you can upload other things to it. It's not just drone information. Um, you may not get the photorealistic texture of the way drone data collection works, but you could get a point cloud in there, and that could be overlaid on top of the files already in there with this color setting on it. And one could go and look at, and I'm gonna choose this because I prepared it, and I know what I'm trying to say. But in here there is this bit on the wall, and this bit on the wall is clearly changed between the two scans, because it is black, which means it's greater than 3 centimeters difference, and there's a little stripe of red here, or red and orange, which means that it's somewhere between, say, 2.5 centimeters up to 3 centimeters different, but it's blue all around it. So something significant has happened to that part of the wall. So let's find out what it is. How do we do that? Well, we refer back to the other types of files we have collected with the ground-based stuff. So we have a ground-based scan before any work was done, and each one of these represents a scan point, and one afterwards, and you can see the amount of work that's been done. There have been drilling, and what we wanted to check was how much movement, or if any, has the facade moved, because it's almost in isolation up there. As you can see from the cloud comparison software, oh, wait, I can't find it. There we are. But most of it's blue, which means that it's right down here in this 0 to 3 millimeters difference. But there are some areas of red. Now, this is all wood, and that could have got wet. There was a month apart between these scans, plenty of rain, plastic sheeting here, and perhaps build-up of dust in the window frame area, obviously greater than 3 centimeters worth because it's got black areas, folded plastic down here. But I want to use this as an example. So let's have a look at the before area. So we know we are looking, I'm just going to quickly flick back and forth to see what we're trying to identify the exact location. I mean, I could go to the coordinate location, and that is relatively simple to do. I'm not going to bring it up on here to slow the video down, but we have 1, 2, 3, 4 horizontal objects on this wall. So I'm going to go up to the fourth one at the end of that is this thing. So let's go to the original. So we've got the horizontal 1, 2, 3, 4. So fine. That's what it looked like before any work was done or in the first scan. And I'm just going to look at some of the photography. So I'm going to go here, wait for the photography to render into high definition. And it's not 4K on this particular scanner. I'm sure as technology progresses, it'll go to 4K, 8K and higher. So 1, 2, 3, 4, and there's nothing there, which is fine because we're looking at one scan. So let's look at the second scan, which was done a month later. 1 horizontal, 2, 3, 4. Okay, so we have something that is clearly different. Let's look at the photography, get to the closest scan point, and we can clearly see, because that was originally an internal wall before any demolition took place, that's wallpaper or some sort of sheeting. And over the course of the month that it took to do this work, it has just become unglued and folded away. And at the time of the second scan, that's what it was showing, or that's the position of where the paper was. So what that's done is identify. I mean, it's all good and well, everything being blue and green and fine and dandy. But what I'm trying to do is identify things that are shown as out of limits and not ideal, so I can absolutely reinforce that the blue bits are correct. So that's the reason why that piece of paper is showing what it is, because anything greater than 3 centimeters turned out to be black. And that's why these floor areas are black, because the ground changed. And I'm going to take away this large three-dimensional point cloud, and we're going to look at one of the sections. And the color is not important. Essentially what I'm doing, it can make it any color. I've made one color for before and one color for afterwards. So I'm feeling in this particular example that, let's have a quick look. This one is before, the white one is before, and the red one is afterwards. So red is afterwards. This is a very small section cut. We can do section cuts from any angle in any location. This is the facade itself on the left-hand side. Everything looks great. And then down here, now I've got to make sure that this retains its sort of orthographic two-dimensional perspective. Um, the, the sandbags have changed. One another sandbag's been piled on top of here, and after the red bit, the ground level is higher. So it looks like work's been done, and then things have been put on top. More ground has been put on top. And there are other examples. You can do cross sections all the way up. You can have multiple and so on. But probably if one is doing a visual inspection, I turn off the sections, put on the decimated version of this again, you will be able to see areas that will draw your attention. So if we come all the way back to the inspection function, this is a nice photorealistic tiled model used for inspecting things, access to the photography. Let's say we had a second scan on a different date. One would have it here, one would go to the comparison function, and you'd be like, yeah, but I don't know where to look to, am I looking over the whole thing? Am I looking through another 1,000 photographs and trying to match one off against the other? Or did Jersey laser scanning load up that colorized point cloud and show me that there are areas that appear to be different, and it'll draw your eye straight in there. And you can go and then compare those areas and click that colorized point cloud on and off, and so on. I'm pretty sure that's it. As far as this is concerned, as far as capabilities, if I think of anything else, I'll add an additional uh, video or something like that. But I've covered iconic locations, um, whatever they may be, point cloud generated, point cloud generated at another point in the future potentially, how to compare them visually and the photography if done by a drone, how to compare them visually and using the photography from a ground-based LiDAR unit. And we are just commissioning our airborne LiDAR unit, which can also be used in SLAM, simultaneous. I've forgotten the rest of it, but basically you can carry the LiDAR unit around. And that will provide a walkable LiDAR-based capability. But essentially, they're all generating point clouds. So you've got a scan of a location on date one, scan of a location on date two. One can generate the photography, georeference it, identify areas that may be different in some way, shape, or form. It could be something hanging off the wall. It'll show a red patch if someone's put an object on top. So if someone lifted a dinghy from here and hung it over the wall, that dinghy would stand out as bright red because it would be greater than whatever centimeters I set it to. Bring your eye to it, zoom in on it, compare the two, see it's a dinghy, and write it off as not important structurally, for example. Um, so that's using Agisoft online, so you don't have to download huge amounts of information. I just send you a link. It's all ready to go, and the photography and the cloud comparison highlights, and then one can inspect things much more closely, should one want to. All right. I hope that was useful. Thank you very much indeed. Bye bye.